Okay, retro, go. Fido, go. Guide, go. Control, go. Telcom, go. GNC, go. Econ.
Humans have always been fascinated by the moon, yet serious lunar research only started in the 1950s. This period marked the development and launch of robotic spacecraft by both the USSR, Soviet Union, and the United States. The first spacecraft to pass by the moon was Luna 1, launched by the USSR in 1959. The first successful soft landing on the moon was achieved in 1966 by Luna 9. However, it was the U.S. spacecraft Apollo 11 that made history with the first human landing on the moon in 1969. Over the following decades, many countries contributed to the study of the moon with lunar orbiters and landers. By January 2024, 5 countries had successfully landed on the moon. Despite these incredible achievements, there remained one unexplored area of the moon: the far side. The far side of the moon is mysterious because it is always facing away from Earth. This results in the far side being completely hidden from our view, which led to the misconception of a dark side, the idea that sunlight never reaches it. However, the far side does receive sunlight, just not at the same time as the side we can see from Earth. To explore this hidden part of the moon, spacecraft are needed to travel there. Thanks to the James Webb Space Telescope, we can now view beyond the moon's horizon, opening a new era of lunar exploration and discovery. Let's delve deeper into the mysteries of the moon's far side, uncovering hidden secrets and showcasing lesser-known aspects of our cosmic companion. When we look at the moon from Earth, we all see the same side, no matter what shape or image we think we see on its surface, whether it's a face, a bunny, or a toad. So, what prevents us from seeing the moon's far side? To understand why, we need to look at how the moon orbits the Earth. The moon's rotation is almost perfectly synchronized with its orbit around Earth. In other words, it takes the moon the same amount of time to rotate once on its axis as it does to complete one orbit around Earth. This phenomenon is called tidal locking. As a result, one side of the moon always faces us. The moon does have a dark side, but it's not always the same side. Depending on the phase of the moon, different parts of the surface are shadowed. For example, when the moon is new, the side we usually see from Earth is in shadow, as the moon is positioned between Earth and the sun. On the other hand, when the moon is in opposition to the sun, the side that faces Earth is fully illuminated, while the far side remains dark. The far side of the moon used to be an enigma, but in 1959, the Soviet Union's Luna 3 spacecraft gave us our first view of it. At the time, the Soviet Union was engaged in the space race with the United States. Although the Sputnik 1 spacecraft was a primitive technology by today's standards, the Soviets managed to send it into orbit around the moon. Luna 3 took 29 photographs of the far side of the moon. These images were captured on film, a technology from the 1950s, which was processed and transmitted back to Earth using a basic scanner system on the spacecraft. Out of the 29 images, only 17 successfully made it back to Earth, and only 6 were deemed clear enough to be published. The photos from Luna 3 provided a radically different view of the moon. They showed that the far side of the moon is much more cratered than the side we see from Earth. This was immediately evident because the darker areas that formed the man in the moon on the near side were nearly absent on the far side. These darker areas, called Maria, are large basaltic plains formed billions of years ago by volcanic activity. In contrast, the far side was far more mountainous and cratered, with some of the craters being so large that they could cover small countries. As the Cold War escalated, the Soviet Union began naming and cataloging many of the features they saw on the far side of the moon. One of the most important findings was the discovery of an enormous impact crater on the moon's limb edge. This crater, known as the Borean Basin, was created by an asteroid impact around 4 billion years ago and is one of the largest craters ever observed on the moon. This discovery gave researchers a glimpse into the moon's early history. In 1965, The Soviet Union launched a follow-up mission called Zond 3. This spacecraft had much more advanced equipment, including a superior camera system and the ability to conduct spectroscopic studies of the moon's surface. Zond 3 sent back 23 high-resolution photographs, which helped to create one of the earliest detailed maps of the far side of the moon. Meanwhile, NASA's Apollo program was making significant progress. President John F. Kennedy had set the ambitious goal of sending a man to the moon and bringing him back safely by the end of the 1960s. By December 1968, NASA was ready to send 3 astronauts on the Apollo 8 mission. This mission marked a milestone, as Apollo 8 was the first crewed spacecraft to leave Earth's orbit and circle the moon. Astronauts Frank Borman, Jim Lovell, and Bill Anders were the first humans to see the far side of the moon up close. They described the lunar surface as a gray, desolate landscape, with round craters scattered across it. During their journey, Apollo 8 briefly lost communication with Earth while they passed behind the far side of the moon. This caused a moment of anxiety for both the astronauts and the mission control team. Astronaut Charlie Duke, who was later part of Apollo 16, recalled how terrifying it was when they lost contact. When communication was restored and the spacecraft reappeared from behind the moon, there was a collective sigh of relief. In May 1969, just before the historic Apollo 11 mission, another Apollo mission, Apollo 10, flew over the far side of the moon. The astronauts aboard Apollo 10 were conducting tests for the lunar module. During this mission, they heard some strange, unexplained noises. This encounter sparked conspiracy theories, with some people believing the moon was hiding something mysterious. Later, research showed that the strange sounds were simply interference from the spacecraft's outdated radio equipment. Once the Apollo missions began landing on the moon, 2 astronauts would descend to the surface, while one remained in orbit around the moon, staying in the command module. This arrangement allowed the astronauts to explore the moon's surface and chart features that had never been seen before. Apollo 15 astronaut Al Worden famously described the far side as being like nothing you could imagine when the sun and Earth were blocked out. The number of stars visible in the sky was incredible, as if they were seeing a sheet of white, with every star a sun in its own right. Despite exploring the far side from orbit, no Apollo mission landed there. This was because the astronauts needed to maintain constant communication with Earth, and if anything went wrong while they were on the far side, they would have been out of reach. Charlie Duke explained that it was essential for the astronauts to stay in contact with Earth for safety reasons. Today, this wouldn't be a problem, as satellites in lunar orbit could relay communication between the moon and Earth. Scientists are becoming more interested in the moon's far side, especially with plans for upcoming human missions. There are many scientific and astronomical reasons to study this region. The idea of placing radio and optical telescopes on the far side has been proposed for many years. Observatories there would be shielded from the sun's glare and from radio interference caused by human activities on Earth. Telescopes in this location could provide a clearer view of deep space and help us explore the farthest reaches of the cosmos. One of the most exciting questions for scientists is how the moon formed and how this relates to Earth's own formation. Research on the moon's surface, particularly through the samples brought back by Apollo 11, has provided new insights into this mystery. The moon is thought to have formed when a Mars-sized object collided with Earth, sending debris into orbit that eventually coalesced to form the moon. This theory is supported by evidence that the moon and Earth share similar materials. However, there are still many unknowns about the moon's past. For example, scientists are puzzled by the discovery that the moon's surface has been impacted by asteroids at various times in its history. These impacts should have slowed down over time, but the Apollo moon rocks show evidence of frequent impacts, especially around 3.9 billion years ago. This has led scientists to propose a theory called the lunar cataclysm, which suggests that a period of intense bombardment occurred during this time. In addition to these geological mysteries, Scientists are also investigating the presence of water on the moon. Water was first detected on the moon by NASA in 2009, and it appears to be concentrated in the lunar poles. This is exciting news for future missions that could use this water for rocket fuel and life support. However, the question of how the moon's water arrived there is still not fully understood. Some scientists believe it may have been brought by comet or asteroid impacts, while others suggest it could have been created by the moon's volcanic activity or by the solar wind. In conclusion, the moon remains a fascinating and mysterious celestial body. As we continue to explore its surface and study its history, we may uncover more secrets about its formation, its geology, and its potential for future exploration. The far side of the moon, once hidden and unexplored, is now an area of great interest for scientists, and we are only beginning to scratch the surface of what it may reveal about our solar system's past and the future of lunar exploration.